more than what the minimum is. So many students actually are concerned that they're not going to do well. But the thing is, it's all about your mindset, y'all. You got to change your mindset. So when you change your mindset, you're able to embrace this information with ease, okay? You're able to embrace it with ease. So let's go ahead and get started with our lesson for today. What I'm going to do is have you all work on a couple of things that deals with some of the calculations. Now, even though it seems easy, I know several students are like, you know what, I understand how to do this. This is easy. Well, here's the thing though. It's easy until you meet a problem that you're like, wait, say what now? Okay, so let's warm up, like just like exercising, I got to get my workout in after this. The schools were delayed in my area because of the snow. But just like with anything, you don't jump up and start working out. You got to warm yourself up. So with these chemistry problems, we're going to warm up. Now, if you were with us yesterday, you know that we were talking about significant digits, significant numbers. And so that's what we're going to look at today. So let's go ahead and get into a couple of these practice problems, okay? Now, here's the thing. To go over the rules really quick, this is like your pop quiz. You know how back in the day, teachers used to give quizzes as soon as you came into the classroom to see if you were studying? Well, this is kind of the same thing. This is your pop quiz. So, but the difference is I'm going to do a quick review of the rules, and then we're going to go straight into your problems. All right. So for rule number 1, when it comes to significant digits, numbers 1 through 9 are significant. So we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Y'all remember that TikTok challenge that everybody was doing when they were saying the numbers and then they said it backwards? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when you have zeros, though, the zeros is what changes the dynamic of whether or not it counts. So I just posted a video that talked about these zeros here. Zeros between significant digits are always significant. So if you have a number like 3009, well, guess what? That 3 and that 9 are going to count, yes, but also the zeros that are sandwiched in between will also count. So therefore, each of these numbers are significant, okay? So that's what we mean about significant digits with the zeros. Now, trailing zeros in a number are significant only if the number contains a decimal point. So again, the decimal point is like a ring. It makes everything of value. It brings significancy to it, okay? Even though people still do what they do in the relationship, but I'm just simply saying the ring signifies value. Everything counts. So in the example number 3, right here with this rule, if I give you a number like 100 with the decimal present, guess what? That decimal is going to make the zeros count because the zeros are after a significant digit. That's the difference. However, if I give you a number like 100 without the decimal, the only number that counts is the 1, and that's the only thing that is significant. Okay, y'all follow me? If you following me, give me a thumbs up. That way I know y'all are listening, okay? Now, on this next part, rule number 4 says zeros in the beginning of a number whose only function is to place the decimal point are not significant. Trailing zeros are not significant. So think of it this way. The zeros that come before, so think of it as these are the zeros here that you see at the very beginning of a number, right? And let's say that you decided, you've taken chemistry or you've taken the TEAS exam several times. Well, I don't want to know about it. That's what the trailing zeros are. I don't care what you did before you saw me. So the moment you enter into my class, that's what counts. So in other words, the zeros that come before this 7 do not count. 7 and 9 are the only 2 significant digits in this particular instance, okay? So that's another way to look at it. The zeros that come before a significant digit do not count. Now, how does this rule change with zeros? Well, it's based on rule number 5. The zeros at the beginning of the number do not count. However, as I had said before, The zeros that come after a significant digit and there's a decimal present is what counts. So this rule right here can kind of confuse students and it can kind of get you in trouble. But what you have to remember are the zero rules more specifically. Where's the location of the zero? Where's the location of the decimal? And the reason why I bring that up is because in rule number 3, there is a decimal present, but it's after a significant digit. The zeros are there also. So if you're after the fact, that's what counts, after the fact, okay? Before don't matter, after does, okay? Here's another example, 0.3800 right here, 38000. The 3 and the 8 count, yes, and so does those 3 zeros, okay? So those are the quick, I would say examples or rules that you need to know before we dive into this quick quiz, okay? Once we do this quiz here, we're going to then go into some other problems where we're going to add and subtract these numbers, and we're going to use a calculator, okay, so that you guys can make sure that you get these numbers correct. Because again, your calculator is going to tell you one thing, but you have to know and be smarter than the calculator, all right? So in number 1, and I love participation, so don't be scared if you get the answer wrong. It's all good because you know what I'm going to do? I'm going to help you get it right. I'm going to give you clarity on how to get the problem right, all right? So for practice problem number 1, right here, number 1, you're going to determine the number of significant digits in these values right here, okay? So you have 0.03. How many significant digits do you see? I'm going to make this a little bit bigger so you all can see the problems too. All right. Okay, let's see. Kenny Key says 1. Okay. All right. Well, you are correct. 1 is correct. Okay, very good, very good. All right. Let's look at number 2, 0.030. How many sig figs are in that number? Okay. Next up, number 3. How many sig figs are in number 3? Yes, you guys are correct. 3 is the correct answer. Very good, very good. All right. What about number 4? 701.0. 701.0. Arlie says 3. Sammy and Lowe and Bailey said 4. Well, the answer is 4. All right, let's talk about this rule here. 701.0. Remember the rule that we talked about before. The 701, yes, all 3 of those numbers count. But because of that decimal being present, okay, and the 0 that comes after it, that's right, Jock, because of the decimal, that is correct. So that's why the answer to number 4 is 3. This one always gets students in trouble. Along with some of the other examples. All right, let's look at number 5. You've got 5,000. That's a 5 with a comma for number 5. How many sig figs do you see here in 5,000 with the comma? Okay, all right, several of you all are saying 1. You are correct. Very good. All right, let's look at number 6 now. Number 6. Number 6, 8,000 with the decimal. Okay, you guys are on it. Yep, the answer is 4. And why? Because 8,000, there's a decimal present. That means I'm going to bring all those zeros to value. So you guys are on it with that one. What about number 7? 5,032.00. Bailey, Jock, Shaquana, all of y'all, Candy Key, y'all are on point. Low, yes. Alicia, yes. 6 is correct. Very good, very good. All right, what about number 8? 0.00003. Yep, that's correct. All right, good job, guys, good job. Number 9. Number 9. Yep, 4 is also correct. Okay, number 10. Yep, 5 is also correct. Okay, number 11. Number 11. 4.25. Don't worry about the times 10 to the negative ninth power. We're not going to take it out of scientific notation. But just look at the base. 4.25. Yep. 3 is correct as well. Okay. And then the last one, 6.7 times 10 to the 8th. Excellent. Y'all did it. Everybody pretty much got 100 on this quiz. Congratulations. Congratulations. Now, let's go ahead and get into these other rules. Now, we started this yesterday where we were talking about adding and subtracting and how you're supposed to follow the significant digits rule when it comes to those decimals. Those decimal points get students in trouble for a number of reasons, and this is because with the decimals, it depends on what's after the decimal, okay, to get your significant digits intact. So here's a reminder of the rules. So let me go ahead and show you all these rules again, okay, just as a reminder, okay. There are 2 different types of rules for mathematical calculations when it involves addition and subtraction and multiplication and division. So hang tight because I'm going to go ahead and dive into this rule. The rule says you're going to limit your answer to the least amount of digits that are after the decimal place. If there isn't a decimal place, then you would say that there are 0 digits after it, and that would be the least amount, okay? Keep that in mind. Keep that rule in mind. So when we look at example number, this particular one right here, you have 152 plus 3.41 plus 2.7. Well, if we look for what's after the decimal place in these 3 numbers, there are 0 digits after the decimal in the 152. There are 2 digits after the decimal. Whoops. And 3.41, but then there's 1 significant digit after the decimal in 2.7. Now your calculator is going to give you this number here that I'm going to highlight in pink, okay? That number there is what your calculator tells you, 158.11, but you cannot put that as your final answer. You have to go with the least amount of digits after the decimal. Least amount of digits after the decimal. So the least amount will be 0. So our final answer would be 158. See that? 158 right here. That's what you would go by. Okay, 158. Now, here's the thing though. You can't get caught up in trying to say, well, this is what my calculator gave me. I know, but you got to go with the least amount of digits after the decimal. Oh, yes, Shaquana, honey, we're going to do another one for sure. Yes, yes. Matter of fact, let's look at this next example. Now, you see right here where it says, oh, you can't see. Hold on, let me. This one right here, let me I'm going to expand it so you can see it a little bit bigger. Okay. So right here, you've got 55.46 minus 28.9. So if we plug this into our calculator, we're going to get 26.56. But here's what you got to remember. There are two significant digits after the decimal for 55.46. There's one significant digit after the decimal. Therefore, we're going to only have one number after the decimal. So that 5 is the number after the decimal, but this 6 right here tells this 5 right there to go up to a 6. So that's why your final answer becomes 26.6. Okay, that's why the answer becomes 26.6. Now, what I'm going to do, we're going to do some more examples, okay? We're going to practice. So what I'm going to do now, I'm going to actually scroll down, but because before I show you the multiplication and division rule, I want to make sure that you guys understand how to do the addition rule first, okay? So we're going to do number 3, number 4, number 3 and number 4. All right, so let me see right here. Okay, there we go. So number 3 and number 4. Let's go ahead and do these problems right here, okay? So I'm going to plug this in so you all can tell me what you get. So I got 12.01 plus 35.2 plus 6. Now, my calculator gives me 53.21. But y'all are smarter than the calculator because we have to go by the rule. We've got two significant digits after the decimal in 12.01. We've got one significant digit, and then we don't have anything right here. So that means we're going to go with the least amount of decimals. So yes, the answer would be 53. Okay? That is the final answer, 53 milliliters. Okay. All right. Let's do the next one. 55.46 minus 28.9. Now again, your calculator is going to give you 26.56, but remember, you have to go with the least amount of digits after the decimal. So what would your answer become? Yes, 26.6 grams is correct. 26.6 grams. That is correct. Okay. Now, what I want you all to do is let's do another one. Let's do a couple more to make sure y'all are good. Okay. Let's look at number, number 6 and number 8. Number 6 and number 8. And good morning, everybody. My name is Professor TK the Chemist. In case you guys are new to my live, welcome, welcome, welcome. I appreciate all of you guys coming in today. My job is to make sure that you all pass that TEAS 7 science exam, particularly the chemistry part, with ease. If you're not taking the TEAS exam, but you're taking chemistry, welcome also. Again, my goal still remains the same, that you guys pass your exams in chemistry with ease. I go live Monday through Thursday at 10 a.m. Eastern Standard Time. Okay, so you guys can catch me here Monday through Thursday, 10 a.m. Eastern Standard Time. All right, let's go ahead and get back to number 6 now. We've got 0.15 centimeters plus 1.15 plus 2.051. Well, again, my calculator is going to give me 3.351 3.351 but you got to go with the least amount of digits after the decimal. Consider that as your final answer. That means we only need 2 significant digits after the decimal. So what do you all get for your answer? I saw some in the comment box. Let's see here. What do you all get? 3.35, you are correct. Remember, the 1 goes away. Yes, the 1 goes away. So 3.35 centimeters, okay? Let me make that a little bit better because that was a little sloppy there. 3.35 centimeters. Okay, number 8. Number 8. We've got 505 minus 450.25. All right, so again, my calculator gives me 54.75. But what should the correct answer become? So I've got 54.75. I am curious to see what you guys get as your final answer. Know that the final answer is 55. Because you will want to know that you go with the least amount of digits after the decimal. So you would go with nothing being after the decimal, but guess what? That 7 that was there tells this 4 to go up to a 5, and that's why the answer is 55. Okay, so far so good. You're welcome. So far so good. You guys are doing well. Now, let's switch it up a bit. Suppose we're now looking at multiplication and division. What do? Well, this to me is a little easier because you have to round your answer to the least amount of the entire number, okay? So you're going to limit and round your answer off according to the least amount of digits in your problem. So that means if I give you those same 3 numbers, 152 times 3.41 times 2.7, I've got 3 significant digits in the first number, 3 significant digits in terms of the entire number now, okay? And then I've got 2 significant digits. That means my final answer is going to be rounded off to just 2. So when I get this number in my calculator, I have to round it off to just 2 significant digits. Yes, 1,400, Vanessa, very good. 1,400 would be the answer. That is correct. That is correct. Because you got to round off based on the entire number. And you know what? I've got some practice problems on rounding that we can kind of get into because I know so many students they forget about how to round the numbers off. They kind of stumble with that, and that's okay. But we're going to practice that also, okay? We're going to practice that as well. Whoop. So let's look at this next example right here, okay? So I'm going to make this a little bit bigger so you all can see it without seeing the answer, okay? All right, so take a look at it. You've got 55.46 grams divided by 28.9 milliliters. Right there. Okay, so you guys should be able to see that. Okay, so 55.46 grams divided by 28.9 milliliters. If we go based on the least amount of our significant digits, you tell me in the chat box what the final answer should become. We've got 55.46 and we've got 28.9. But this is what the calculator told us or gave us. What should your hello? Let's look at these sig figs. You've got 4 significant digits in this first number. You've got 3 significant digits in this last number. So we only need 3 of these numbers. This 9 tells this 1 to go up. So the answer becomes 1.92 grams per milliliter. So yes, that's the final answer. The final answer should be 1.92. Okay. Now, you know we got practice problems, right? So let's go ahead and get into those practice problems. Okay. So let's do number 1 and number 2. Number 1 and number 2. Okay, so let's see what the numbers are. So you've got 1.35 times 2.467. Okay, so my calculator gives me 3.33045. All right, so we know we only need 3 of those numbers, and so far I saw 2 answers that came through. 3.33 is the correct answer because that 0 doesn't make us go up or down. We just keep the number as is. So the answer becomes 3.33 meters squared. Okay. Make sure y'all are practicing with those units also, including the correct units, because as teachers, we do take points off for not having the correct units there. Just FYI. Number 2, you've got 1,035 divided by 42. We get 24.642. I'm just going to give out the first couple numbers. 24.642. 24.642. Well, remember, we only need 2 of them because of our significant digits rule. We go with the least amount of digits. So tell me in the chat box what your final answer is. And with over 50 people in here, y'all continue to tap. Let's run these hearts up, guys, to at least 5,000. Okay, Rihanna got 25. Mar has 24.000. Wendy has 25. Okay, let's see who's correct. The answer is 25. It's 25. Not 24.000. Mar, if we put 24.000, you know what that does? That increases the number of significant digits. So we don't want to say 0.000. And also, you didn't round the 6 told the 4 to go up to a 5. So the answer is 25 meters. Okay, 25 meters. But we got some more practice just in case you kind of stumbled on that one. That's okay. We're going to go to the next one. Let's see here, y'all. Let's look at number 5 and number 7. Number 5 and number 7. Run it up to 5,000 and I'll reveal the answers. Okay? Run it up to 5,000 and then I will reveal the answers. Okay, so we had 0.021 times 3.2 times 100.1. And let's see here. So yes, run it up to 5,000 and then we will reveal the answer. Okay. So keep on pressing, keep on pressing. Let's get those hearts up to 5,000 so we can see what the answers are. Let's run it up, run it up. Okay, Sherry or Shari says, so for number 8, even though it has 3 significant digits, you don't put any behind the decimal. Okay, now remember, I don't know when you had come in. When we were talking about adding and subtracting, the rule says you go with the least after the decimal. So the rules are different for decimals for adding and subtracting versus multiplication and division. So when you're multiplying and dividing, you have to look at the whole number. When you're adding and subtracting, you look at what's after the decimal. Okay? Very good question for clarity. Very good question for clarity. All right, y'all. We're almost at the 5,000 hearts for us to reveal what the answer is. And make sure you include your units. So Lo says 6.7 centimeters, or will we do 6.7 cubic or square centimeters? Well, there are 3 cms. Therefore, you would have to have. So for number 5, the correct answer is 6.72. I'm sorry. 6.73. 6.7. Look, can't get my numbers right. 6.7. Sorry, y'all. 6.7 cubic centimeters. I was looking at the whole number. All right, so we're going to do number 7. $150 liters cubed divided by 4 liters. Let's see what you guys get for that one. 150 liters cubed divided by 4 liters. So this is what the calculator gives you. Yes, it gives you 37.5, but you only need 1 significant digit. Remember that, guys. You only need 1 significant digit. So 37.5 is going to become what? Now, let me write it big so y'all can see that. 37.5, you only need 1 significant digit. So what does that 7 tell that 3 to do? What is that 7 going to tell that 3 to do? That 3 goes up to a 4, but the 4 becomes 40. It becomes 40. 40 liters square. Because remember, if I owe you $37.50, you can't tell me, and I say, give me my money in 1 significant digit. You cannot say, all right, give me $4. No, I need to give you $40. You know, that's a little interest built in. So when you round off 37 to 1 significant digit, the answer becomes 40. 40 without the decimal. 40 has only 1 significant digit. Oh, it's okay, Lo. I got you. Oh, YL square, very good question. If you have a cube up top and 1 on the bottom, when you subtract 3 and the 1, you end up with 2. That's where the L square comes from. Wait, so the 4 needed to be included? Yes, it becomes 40. Because remember, the 3 right here, that 7 tells the 3 to go up to a 4. That 7 is a placeholder, so you've got to have a 0 there as a placeholder for that part. Yep. So that 7 told the 3 to go up to a 4, and that 7 gets replaced with a 0 as a placeholder. Yes. And you know what? This is a great segue, guys, to this right here, to rounding, to rules of rounding. Because so many students, like I said before, they get confused with the rounding stuff. And so this is a great way to establish the rules for rounding on this. So for these, I want you to round. We're just going to do some of them, okay? We won't do all of them. We're just going to do some of them, okay? We'll do 10. We'll do 10 of these problems, okay? We'll do 10. All right, so let's just go really quickly. Round off 86 to 1 significant digit. What does 86 become in terms of 1 significant digit? 90 is correct. Remember, think like money. Think like money. If I owe you $86, but I'm going to give it to you in 1 significant digit, 90 is the answer and not just 9. Okay? 90. So you got to add a 0 for that placeholder. So that 6, you still have to account for every digit. Keep that in mind. Speaking of which, what's the answer then for number 2? All right, Ash put 70. You are correct. 70 is correct. Okay, number 3. 60, yep, 60 is also correct. Number 4, 4. LA, how many sig figs do you have in your number? Candy Key, how many sig figs do y'all? Look at y'all's numbers. If you put 330, how many sig figs do you see? How many sig figs do we supposed to have? Jason, you are correct. 300. 300. One significant digit. 330 gives us 2. Number 5. Number 5. Yep, 700 is correct. Number 6. Number 6. $300 is also correct. Okay. Number 7. Number 7. $1,700. How much is it in one significant digit? Y'all got it. 2,000. Very good. Very good. Number 8. Number 8. 2 is correct. Just 2. So here's the thing. You got 2.47, but remember, we only need one significant digit. So that 4 tells that 2 to stay put. All right, there you go. There you go. So yes, just 2. And number 9, what did you get? Number 9. Okay. And the last one, 11.70. I only need one significant digit. I knew y'all were going to say 12. No. The answer is 10. And I know you're saying, how? Remember, 11.70. We only need one significant digit. This one that I'm highlighting in yellow tells the green one to stay put. So you replace the yellow one with a 0. So that's why it becomes 10. And that's one significant digit right there without a decimal. Okay, and this is one of the videos that I did earlier on scientific reasoning, because scientific reasoning is also on the TEAS exam. Okay, so yes, so you all can also go there too to see my YouTube channel. So it's Learn Chemistry with Professor TK the Chemist.